Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael, and in studio with us today we have Simon. And Simon, if somebody wanted to get hold of us to Do the Math, what would they need to do?
Well, for math homework, help call in Bakersfield 636-4357. Toll free 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
All right, now it's my understanding that you've got some fans getting ready to watch this live online, and then a lot of people ready to catch it on YouTube later, right? Mm-hmm. Oh, you're going to be world famous in a little while, I'll tell you that right now. Why don't you let everybody know where you go to school and what grade you're in, first of all?
Well, I go to Reagan Elementary School, and I'm in the 6th grade.
How long have you been at Reagan?
I've been at Reagan for actually 8 years because I started in transitional kindergarten, and then we've just stayed there. So this is my 8th year.
So you've been there a long time.
Yeah.
So it's kind of like home.
Yeah.
Almost, right? Because
Yeah,
I mean, you've been there 8 years now.
Like
What do you think will be one of the things that you miss most when you leave Reagan next year?
To be honest, I feel like I'll miss most is that my brother told me that in like Warren in high school, you have different teachers for every class and you'll always constantly be on the move. I feel like something I'll miss about Reagan is the fact that you don't have to like find and have to leave new classes. So I feel like that'll be it's easier to do it with one teacher in all subjects.
Okay. So you'll miss that, but do you look forward to having other teachers a little bit? Or?
I mean, yeah, I do, because I feel like sometimes it's hard to find a teacher who's so good in everything. So that's why you need to have teachers who like major in math, English, and so on.
Right, so they can focus on one thing with you and help guide you and have you learn a little bit more in those areas, right? Mm-hmm. All right, you ready to do a little math today?
Yeah.
All right, head on over to the board. Yesterday we were talking about exponents, and I know that you are quite comfortable with exponents now. Yeah. So what I'd like you to do is explain this division problem, all right? Okay. So here we go. 4w to the negative 4th power, k to the negative 2nd. And that's going to be over 3w k to the negative 3rd. So as you're doing that, if you could explain to me what you're doing, and then we'll see what you come up with at the end.
Okay, so what you do in exponents with division is first you're going to want to rewrite the problem, except when a number with a negative exponent, the whole goal is to get it to the bottom and make it positive. And to do so, you have to flip it to the bottom. So what I'm going to do is 4w, so I'm going to rewrite it right here. 4w, negative 4. What you do is you subtract it from the bottom number, so then you're going to get 7. So then,
you got,
that's 1.
There you go.
So actually, there's an imaginary 1 here. So it's a negative 4 minus 1, which is also known as negative 5. But if you want to change it, then you could just switch it over and make it 1 over 4w to the 5th power.
Okay.
And then, when you rewrite the problem, it comes out to 4wk negative 2 over 3w 5th, and then k negative 3. So now that we've solved the w side of the problem, we're going to want to do the k side. So I'll move over to this side. To get the k, you're going to subtract it, and then when you have negative 2 minus negative 3, when you have two negatives, a negative and a negative exponent, it's called keep change. So then you change it to positive. So negative 2 plus 3 is really 1, is equal to 1. So then what you're going to do is now you can rewrite this problem as 4k over 3w to the 5th. So then the answer to this problem would be 4k, 3w to the 5th.
There you go. Nicely done. Great explanation on that also about, and I like the part also about where you had the -2 minus a -3, the explanation of that. So let's do one of those again. We won't do another exponent problem, but go ahead and clear the board. There you go, nicely done. All right, so let's try this. Let's try -4 minus a -7. And just one more time, explain what's going on there, because when students see a lot of negatives, that might confuse them a little bit.
Yeah, so as a student, I understand how you can see so many negatives and you think, okay, with so many negatives, that must mean you subtract, but maybe there might be a little different meaning. So you kind of worry and you might do -4 minus 7, which will get you the wrong answer of -11. So that's the wrong way to do it. The correct way is this process called keep, change. You keep the first sign, which is negative, so you keep -4, and then you change the other two by changing a negative sign to a positive. And then now it's a more simpler equation. When you have two positives, that's just 1. So -4 plus 7. And when you think about it, it's not -11 because look, a negative plus a positive, the positive goes into the negative. So it's almost like 7 minus 4. So then 7 minus 4 is 3. So then 3 would be your answer.
There you go. Beautiful explanation once again, because a lot of times students will go, oh, I know what 7 minus 4 is, it's 3. But if you reverse the order and go -4 plus 7, it throws them off a little bit. But nice explanation on that. Well done with that. All right, we do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. Phone numbers are at the bottom of your screen periodically throughout the program. Time now for today's Math in the News. All right, today's Math in the News has to do with something that I love, and I'm sure you do also, food. You like food?
Obviously, because we have to eat it every day.
That's right. We have to eat it every day. Well, there's some people, they don't eat a lot, or they fast sometimes and stuff like that. They said no to that, right? They said no to that business. But anyway, do you have a favorite food? Like if somebody said you can have a meal, anything you want, what would that be?
To be honest, I would prefer it depends what type of day, but as a dessert, definitely would be ice cream.
Oh, so you go in dessert?
Yeah.
All right. Now, let's say your parents go, you know what, Simon, that's nice. You can have some ice cream as dessert. We'll give you any ice cream you want, but you must eat a meal first.
A meal?
So what would be the main item?
To be honest, it would probably it could be a Subway sandwich or maybe a fast food burger is what I prefer.
You like Subway sandwiches? You like sandwiches and burgers?
Yeah.
If you go to get a sub, what kind of sub do you like?
I like a turkey with American cheese and then lettuce, pickles, and then mayonnaise.
All right, there you go. Nice and easy. I guess some other people agree with you on that one. All right, well, here we go. Here's today's Math in the News, because a lot of times people like going to these places, and a lot of times they just want to stay home and have it delivered. So here's a little something I found. 91% more expensive if you have that item delivered. Now, that doesn't mean it's 91% every single time as far as the increase, but there are markups that go up to 91%. So if you knew you had to pay 91% more, do you think you would order food as often to be delivered?
No, I would, because I feel like this extra charge, maybe you want to feel like you want to stay back and deliver, but when you really think about it, 91%, that can add up, and eventually that money that you wasted on delivery, you could have just went and picked up and had extra money to spend on whatever you like.
Okay, well, let's take a look at this right here. Here, it's funny because you brought up Subway. So this is an order for a Subway sandwich, all right? And we can see that the cost of the turkey breast sub is $11.98, and that's for 2 of them. 2 6-inch subs, okay? So we'll just start with Grubhub here. So it costs $11.98 as far as Grubhub is concerned. Now, if you went to the restaurant, it would cost $12.58. So it's actually a little less on that part. But they have a delivery fee, they have a service fee. Obviously, there's going to be sales tax, but the tax is going to be on top of all of these fees as well. So the total cost would be $16.46, and you can see that's a 25% markup, which you would expect a markup because you're paying for the service of it being delivered to you. But then we can see some of the other companies that deliver food, and we can see that in this particular case, so we're not getting on any company, but this just happens to be this one, Uber Eats is charging $25.25 altogether for a $14.78 sub. So that's almost doubled, right? Which is where we're getting the 91% markup. So you can always take a look, and this is kind of an example of how you can take a look and see, all right, do I really want this delivered? Is it worth the cost to have that convenience? And there are times when you may need it delivered, right? But then you have to think, all right, is it something I need, or is it, I'm a little lazy today and I just want to have somebody deliver the food, right? So anyway, that is today's Math in the News, the markup on different priced items right there. 636-4357 is the phone number. We have Simon in studio, a 6th grade student from Reagan who has been there 8 years. And some people might be going, well, he's in 6th grade. How has he been there for 8 years? But you did the transitional kindergarten and then kept on going through that. Do you remember anything from transitional kindergarten?
To be honest, I don't, because there was no educational system in that. So it was basically just fun and games where you could just play outside.
And kind of learning how to go to school, right?
Yeah. So
all right.
you're used to it eventually.
Do you have fun and games like that in 6th grade now?
I mean, like it goes down every year, so this time you just get recess.
All right, so but you still have time for fun and games. All right, well, you know what? We have time right now to visit with the Kern County Farm Bureau and see the role that bees play in agriculture.
Well, good afternoon and welcome to Math in the Real World, the favorite part of the show. I know it's my favorite part of the show because we get to get out here in the real world, see where the numbers collide with actual real life. And this is one of the really neat places that we have come to find here in Kern County. We are in an almond orchard, and we want to know about how the heck almonds are made, specifically how they're pollinated, because that's a really big part of Kern County agriculture and a really big part of the interest, I know, of a lot of young people out there. So we want to learn about bees today. So I brought my friend Breanne. Bree, thanks for your time.
Hi.
I appreciate you being with us today.
Thank you for having me.
Tell me a little bit real quick just about what you do and how the heck you got involved with bees.
Okay, so at this time of the year, we are pollinating almonds. And this time of the year, I do colony strength inspections.
Okay.
I ensure that the 8-frame average is there that the farmer is paying for.
Gotcha. So the farmer wants as many bees as possible to come into the field, right? And without a bee, right, this flower does not become an almond. It has to have a bee visit it.
Yes.
Once, twice, 3 times, 10 times? At least once, right?
At least once, at least once. When the bee comes to visit, they're actually coming to drink off the nectar that is held in the bottom of the petals there. And going from flower to flower to flower, they pick up pollen on their little pollen sacs on the back of their legs.
Right.
And when they do so, visiting from flower to flower, they cross-pollinate the pollen from flower to flower, and when that petal closes, it forms an almond.
There you go. So you got to have a bee. Make sure it hits every single, or at least as many flowers as possible. So the farmer wants a lot of bees out here.
Yeah.
So you talk a little bit about an 8-frame colony. So bees come in a box. Most people have probably seen those, especially in Kern County. If you're driving along the roads, you see pallets of boxes. Inside each box are frames, right?
Yes.
What's on a frame? Like, why are the bees arranged in a frame? What's that all about?
The quality and the quantity of an almond orchard is dependent on a healthy pollination.
Okay.
So inside each box, the farmer wants to see an 8-frame average because that's what they are paying for.
Okay.
And in order to ensure that investment, we come out and inspect those boxes. And when we inspect those boxes, we get a good average count for the for the frame count in the yard.
Gotcha.
Or
And
the
just to be
orchard.
clear, a lot of people think of honey directly correlated to bees because, of course, bees make honey. But you're not looking at honey right now. We are just mainly interested in pollination and not honey production. Is that correct?
Yeah, I mean, it can be kind of tough to calculate the exact number of bees on an orchard, but we can come pretty close.
Okay.
When we are looking in a box and when we open up the box, we want to see a line of bees going all the way across the frame on each side of the frame, and we count that as one. When we inspect an orchard, we inspect 25%. So if you have 1,000 boxes on one orchard, you would inspect 250 boxes. And with that 250 boxes that we inspect, we calculate how many frames are on each box. We total that number of frames, and then we divide it by the amount of frames or the amount of hives that we inspected. And that's how we get our average frame count for an orchard.
Right. So you're really doing a kind of a quality control deal for the farmer, right? You want to
Yeah.
know if the farmer's really getting his money's worth.
Yeah, but what's beneficial about it is it also is a great benefit for the beekeeper as well, because we provide a paper trail reputation for the hard work that they've done, and they deserve that, especially if their frame counts are above that 8-frame average.
Right. Right. Good deal. So, okay. So in a, I don't know if I can throw some numbers here at you real quick, but I'm going to try. In a 40-acre parcel, that seems like a nice round number for agriculture, right? In a 40-acre parcel, how many boxes of bees should be there for good pollination in an almond orchard?
Per 1 acre,
Per 1 acre.
yeah,
Okay.
is about 1.75 hives per orchard.
Okay.
So somebody quick with a calculator.
So 1.75 per acre.
Yes.
Gotcha.
Yes.
So it'd be 1.75 times 40, so that'd be about 70 boxes, right?
Yes.
70 boxes per 40-acre parcel.
Yeah.
So
get
that's
the
a lot of
quality.
bees to bring in.
Yeah, it is.
Yeah.
Yes. For the state of California, we need roughly 80% of the country's bees to pollinate our orchards. And what's so amazing about this specific area is it's 1 in 5 counties that can produce the almond orchards that we have.
Right, right. Oh, such a unique niche of the market here to be producing all these almonds for not just the country, but for the world. We produce a lot of almonds here in Kern County.
Yeah, yeah.
And they all have to have bees. Well, I really want to go take a look. I
Yeah.
know we all want to go take a look. And so when we come back, we're going to see if we can get into some suits, get into this equipment, make sure that we're as safe as possible. But we also want to get in there and see some doggone bees, man, see what's going on there. Maybe we can ask them some math questions. Right now, I know there's some more math questions back in the studio. We'll be back to dive into a hive.
All right, thanks for that, Scott. And yeah, we'd love to see you guys dive into a hive, but I guess they will have their suits on in a little bit. And out there working with the bees and the almonds. Do you like almonds?
I do. I like airplane rides, but particularly, I would not like to eat them for lunch or anything.
All right, so you like them on the airplane,
Yeah.
but you wouldn't eat them normally.
Yeah.
All right, well, that's all right. You know, sometimes that's the first time people are introduced to almonds. You know, they get them on the snack, is on there, and the other bread. I love almonds. They're so good. I love them, and they're good for you.
But,
You know, it's one of those snacks that you go ahead and eat a ton of them if you want. All right, you ready to do some more math? All right, you and I are going to do this one together right here. So we have 16, and it's being broken into a bunch of different shapes. And sometimes students see shapes when they're being introduced to equations in algebra. You might remember maybe in 1st or 2nd grade, they may have had a star, where they might go, star plus 3 equals 4. So what would the star equal?
Star
So
would equal 1 then.
Right, star would be 1, right? But sometimes they look at it and they go, I don't know what a star is. I don't know what it's worth, right? Just like when students are introduced to pre-algebra doing equations and they have to solve for variables, right? They see an n or an x and it kind of throws people off. But once you understand that it simply stands for a number, it's a little bit easier, right? So kind of what we're going to do right here. We can see that 16 is broken into a couple of different shapes. How many different shapes do you see there?
In total,
In total.
7.
All right, so there's 4 different shapes there. And how many different ones are there?
Oh, there's going to be 3 different ones.
3 different ones. Do you know the names of those?
Star, and then, star, hexagon, and then triangle.
Right, okay. Now, is there a clue or a way that you know that that's a hexagon? Is there a little thing that you've got in your head where you
yeah.
know that's a hexagon instead of trying to think of
Yeah,
octagon
because-
or whatever?
So like there's names for each shapes, as in like, and they're determined by the amount of sides in each shape. So like a triangle is a 3-sided figure, a hexagon is a 6-sided figure, and I counted the sides.
Okay.
And I counted to 6, so I knew it must be a hexagon then.
There you go. And we know triangle because tri means 3,
Yeah.
right? Hexagon, 6, and you can remember because it's got the X in it,
Yeah.
right? Okay. So we know 16 is going to be broken into all of these different numbers. And every time a number, so whatever number you think is for the hexagon here, it's also going to be the same number in these hexagons. So whatever that star is will be that, and then the triangles will be the same also. So what can you tell me, just by looking at this setup right now, what can you tell me, what's the first thing that comes to mind?
I start thinking about the star because I see like the 16 and then it divides into 2 things.
Okay, so if it divides into 2 things, what do we know those 2 things have to be?
They have to be equivalent.
They have to be equivalent, and what do we know they're going to be?
They're both going to be 8.
They're both going to be 8, right? So the very basic thing right there. We know that it divides into 2, so both sides altogether have to equal 8. Now what would you like to do?
So now
So
what
I'll
I
just
do
put
is,
8 up here for us.
okay, so I see 8 on both sides, and let's just protect the right side because it's a smaller amount of shapes. So what
Okay.
you're gonna do is, you see the 8, it goes down and splits into 2. So 8 divided by 2 is equivalent to 4. So then each side must equal 4.
All right, excellent. So we'll do that. We'll keep on going.
So then as I can go down the right side of that 4, I can see that it's just a star by itself.
So that's
then
gonna
the
be 4.
star has to be equivalent to 4.
All right, so we'll put 4 right there.
Yeah. And then I can see on the other side, the 4, it gets split up into 2 different things. So 4 divided by 2 equals 2.
So what would you like me to do? 2 on each side here?
Yeah.
Okay.
And then as you can see, there's 2 triangles. So, and then 2 divided by 2 equals 1. So then each triangle equals 1.
All right, so we'll put 1s there.
And then the hexagon, since it's the only shape on the 2 side carrying the weight, it has to be 2.
Excellent.
And then you can fill in the information on the other side.
But I don't understand what's going on. You need to tell me what's going on because I might get confused. It's like, all right, I know it's 8, but I saw how you got 8 there. So how do I do it on this side? Because there are going to be students that don't follow it all the way right now.
Okay, so then now you can go onto the other side and then you just restart the step-by-step process. You see that 8 gets divided into 2 different sides and you divide 8 by 2, which equals 4. And then let's just say the star, because it's only one shape, if you look down, the star is the only shape by itself, so the star has to equal 4.
Okay.
And then since there are 2 hexagons, you divide the total, which is 4, on top of it. 4 divided by 2 is 2, so each hexagon equals 2. And then to check your work, you can look on both sides and see, okay, on the left side the star equals 4, on the right side the star equals 4. Hexagons 2 on both sides, so then that's how you know that you must be correct with your answer.
There you go. Excellent work right there and great explanation. Now what I'd like you to do is, since we just did that one together, I'd like you to go over to the board and I would like you to work on the number 24 and explain the process once again as you do that problem.
Okay, so as we can see, number 24, that's an even number, so you can divide it by 2. Because as you see, 24 comes down and goes into 2. So there's 12 and 12. So let's just do, I guess, this side. And as you can see, 12 gets separated into 3 different things. So 12 divided by 3 equals 4, so you put 4 on each hanger. So as you can see, for example, since there's one shape right here, this shape has to equal 4. And there's one shape over here, so this shape is 4. And then you see that there are 2 shapes underneath the 4, so you divide 4 divided by 2, so you get 2. So each triangle is 2. And then now we can restart our step-by-step process onto the right side, and as you can see, 12, it's split up into 2, not 3, so 2 this time. So just because you saw 4 here doesn't mean it's 4 here, you have to retry it. So 12 divided by 2, because there's 2 splittings, it equals 6. So you put 6 on each end.
And I just want to make sure, so we're going to stop you for a moment. On the farthest right, under that 6, that is a square instead of a rectangle.
So it's a different value.
Right, so I just wanted to make sure that everybody sees that that's not as wide as the other rectangles, so that is going to be a square at the far end.
Okay, so then now what you can do from here is that 6, since there's 2 shapes, but look, there are different shapes, and since the values aren't equivalent, you can't just do 6 divided by 2 equals 3, because if you put 3 in each square, then it doesn't correspond with this thing, which is 4 and 2. So what you can do is you can look onto your left side and then fill on this, 4 and then 2. So then now you see that the weight is correct because 4 plus 2 equals 6. So your string is still going. And then as you can see, the triangles are 2. So then you're going to put 2 in each triangle. And then this thing, so look, 2 plus 2 plus 2 equals 6. And since 6 already equals 6, the value of this square, which isn't the same as the rectangle, has to be 0. Because you can't, any other number would make it too high. So then that's my total answer for this question.
All right, that works. You know what, I'm going to have you leave that up there because we're going to take a look at it again in just a couple of moments. But just a reminder, we do have Simon, a 6th grade student from Reagan Elementary, working in studio today. And for some great work thus far, you've got yourself a meal courtesy of our friends at Chick-fil-A. So congratulations on that. We'll have Simon do some more work, and we'll check in with the bees a little bit after this. Today we're at Mojave Elementary, home of the Colts, and we're here to
Do the math!
All right, once again, we're at Mojave Elementary, and we have some 4th and 5th grade students working on integers, right? So once again, what are integers?
Integers are negative and positive.
Negative and positive numbers, right? So we learned a little bit about where to find them on a number line, right? And then we also did some ordering, where we found out if one was greater than or less than, or possibly sometimes equal to the other number. Now we're going to put them in order, all right? And we're going to take positive and negative numbers and put them on a number line to see where they fit, okay? So let's take a look at the first set. So the first set, what does the number line start with?
7. Positive 7.
Well, let's take a look at the number line underneath it first. What does it start with?
Negative
It
12.
starts-
Negative 12.
12.
And what does it go up to?
Positive 12.
Positive 12. So we know all the numbers are going to be within positive 12 and negative 12. So the first one, 7. So go ahead and circle where 7 would be. Easy enough, right? Everybody's got positive 7?
Yep.
Okay. What about the next one? What number is that?
10.
10. All right. So go ahead and finish up that first set. Let's go down to the very bottom one. Now, there are more numbers there, but what are they all going to be between?
They're going to be all between the,
So what's the highest number on the number line? 12. And the lowest number? Negative 12, right? Always remember that negative, all right? Because otherwise 12 and 12 would be the same, all right? So try the bottom set, set 7. So a lot more numbers, but as long as you keep yourself organized, they're going to be easy enough to find. Now, some of the numbers that we have, so the first number we have is a 5, positive 5, right? And there's a negative 5 in that set also. So think about this. If you were at 5, all right, so go ahead and put your pencil on 5. Okay? And now we're going to add a negative 5. So if we're at 5 and we're going to add negative 5, which direction do we need to go? Towards the 0 or away from it? Towards it, right? Because we're taking away 5, right? So 5, so if you're on 5 and you take away 5, where will you end up at?
Wouldn't it just be 5?
Well, it would be 0, right? Because you're at 5 and you're taking away 5, right? So you're going to end up at 0. So now what we're going to do is we're going to move into adding integers, all right? So all you need to do is pay attention. We'll look at, see if it is a positive or a negative number that we're going to be adding, all right? So let's take a look at the first one. Read the first one.
Negative 3 add
Positive 12, right? So negative 3, so put your finger on negative 3. Well, take your number line if you want. So let's dig out your number line. All right, so where's -3? Okay, and now we're going to add 12. So you're going to go positive 12.
9.
I have to go -3 plus 12 is going to leave us at 9. All right, you ready to try one more?
Yeah.
All right, let's take a look at the next one. So -15. Okay, if you're at -15, all right, and you're going to add -3 more, where do you think you're going to end up at?
-18.
There you go. Now, how did you get -18 so fast?
Because I just added the negatives.
Right, you add the negatives, right? If you're down 15 and you go down 3 more, you're going farther down, right? So there we go, a little bit more work with adding integers, comparing them, putting them on a number line, and seeing how they fit all together in a set with the students at Mojave Elementary. And once again, a big thanks to the students over at Mojave Elementary. Had some great work with those guys. We do have phone tutors available until 5:30 this afternoon. We have Simon, a 6th grade student from Ronald Reagan Elementary, and you did a perfect problem on the 24 right there. Now I have, this is a bonus part for you, all right? Because you did it perfectly, and we saw that the square was equal to 0. But my challenge to you is nothing can have a 0.
Okay.
So now, how would you like to do the problem? Because it's going to work out a little bit differently. All right, so head on over to the board. And instead of the 4, 4, 4 and the 6, 6, it's going to be a little different now, isn't it? All right, so go ahead and erase the 4s and 6s. And as you go through it this time, kind of explain your reasoning also.
Okay. So now that he said there's no zeros, which wouldn't allow my process to work of the 2, 2, 2, 0, because in that case, like the square, I guess would have no value. So then, I guess since there's 3 and they don't all have to be proportionate, I guess we could try. Let's just go back to this side and maybe we could try to keep that 6.
Yeah, because as long as it adds up to 12, it's fine.
Yeah, it's okay. So any 3 numbers. So I guess in this case, like we have to do an even number since these are 2, because decimal would just make more work and things. So I guess I'll do an even number. I guess we could just do 2. And then since these are the exact same shape, they have to be equal. And 12 minus 2 equals 10. And then 10 divided by 2 is 5. So it's 5 on each side.
All right, so far it makes sense. And it's working out so it's balanced still. All right, keep on going.
Okay. So then now we see that there's one shape on this 5 side, so this shape is a 5, which means ultimately you could go to every rectangle and just go fill in 5 if you want your thing to work. And then 2, since there's 2 shapes and they're both equal, they have to be 1 each. So go ahead and go fill out all your... Okay, so now that we have a 1 in all of the boxes, now we can just, since this side's already filled out because of these 2, let's find this new square. So 1 plus 5 equals 6, so our work works. 1 plus 1 equals 2, 5 plus 0 equals 5, and 5 equals 5. So now look, 1 plus 1 plus 1 equals 3, and then 6 minus 3 equals 3. So then this square, which is unique from the rectangle, is equivalent to 3.
There you go, perfectly done. So you've solved it 2 different ways. One in where the square was going to have a value of 0, but then also where the square has a value of 3, because otherwise we were talking, you could put squares all over it if they value 0, right? All right, nicely done. Well, you know what? We do have another opportunity. Let's see if they have their suits on as we go visit with Scott and the Kern County Farm Bureau, checking out with the bees.
Welcome back. Math in the real world, and look at me, really getting ready to see these bees. Here we go. We're excited to get into a beehive. Bree, here we are. You have much less equipment on than I do. However, I'm not going to claim to be the expert that you are. Obviously, you know what you're doing. but I feel protected with what we're doing. What do you got in your hand, first of all?
Okay, so this is my smoker.
Okay.
Bees communicate with dances, but they also communicate with pheromones.
Okay.
This breaks up that pheromone communication. When bees become upset, they give off a banana Laffy Taffy smell in the air. It's a very sweet smell, but we don't want to smell that today.
Right.
Also, it kind of resembles a forest fire. So anytime that any emergencies come close, or they may have to abscond very quickly, it's their instincts to gorge as much honey as possible. So when we smoke that hive, they're busy gorging on honey and not so worried about us.
There you go. Good deal. That's a good thing, because every once in a while, I mean, usually when you open up a hive, you're taking the roof off and rearranging their furniture, and not everyone likes when that happens. So we've got to distract them a bit, right?
Yes, yes.
Okay, well, let's go take a look. I know John's going to help us out here a bit as well.
Yep.
So we're looking at a whole pallet full of hives, right?
Yep, yep. And before we open up a hive, it's important to smoke the entrance. And if you give them just a few minutes for the smoke to rise through the box and for them to distracted by gorging in that honey, then we have a little bit more of calmer bees than if we just lifted it.
Gotcha.
But yeah, go ahead.
And while you crack this, I just got to ask, because I know people are interested. You're going to work these bees with no gloves. Why do you feel comfortable doing that? Tell me a little bit about that real quick, if you wouldn't mind.
It's all about understanding bee behavior.
Okay.
The first thing that I like to do when I open up my hive is just smoke off the edges here. That way I can work the bees comfortably without smashing any of them.
Sure.
It's just important to remain calm and stay calm and not squish any bees and just work slow. This box here is lined with a whole lot of propolis. Propolis is another wonderful medicinal
it's a product that the bees make,
yes,
right?
that they
I've
make.
heard it even went on the space shuttle or something like that. It's an unbelievably strong product that they make.
Yeah, it's super sticky, and it's got a whole lot of benefits to it.
Okay.
Yeah.
So they've kind of welded those frames into this box pretty well with all the propolis on the edges, right?
Yes,
Okay.
yes. And if we were doing an inspection on this box, the first thing that I would want to take note of is how many bees and how far wide that cluster is.
Okay.
So here we can see, it's kind of hard to see that there are bees along this side here, but with the work that they've done, I would imagine underneath here on this side we have a large amount of bees. So if we have bees on this side, and we can see bees working this side and this side of the frame. So each frame where the bees are working both sides of the frame count is 1.
Okay.
So here we would have a frame count of 1, 2, 3, 4, 5, 6, 7, and then this one, we do have some work, so that would be up to the inspector, but I would say this is a solid 8 frame count of bees.
Gotcha. And those are 8 frames, and then again, that one looks a little different in the side there. Tell us what's going on the edge there.
Okay, the beekeepers, especially when you're commercially running this many bee boxes, it's important to supplement the bees. Here is a syrup feeder. Oftentimes this time of year, a beekeeper is feeding ratios of sugar water 1:1 or corn syrup, just to help production and to help stimulate that queen to start laying eggs.
Gotcha. So this is the extra little food inside the box.
Yes, absolutely.
So some of the bees don't even have to leave the box to get their meal, and some of them do, right?
Yeah, and preserving their energy is really key, to help build that box stronger in time for pollinations.
Gotcha. Okay, again, from your experience, can you tell us, why are these bees so ridiculously calm? I mean, maybe, are they just so happy to be in California in the middle of February and it's 75 degrees, or because all the almonds are ready? I mean, they're just so chill. I'm glad I have my suit on, but it's almost like I wouldn't need one. You don't have one on, and you don't seem to be bothered by them at all.
Understanding bee behavior is why, and bees they want to defend what's in there, but they really don't want to bother you just as much as we don't want to bother them. They tend to mind their own, and they're pretty docile for the most part.
Yeah, no doubt. Now, I know there's a big entrance on the front here, but there's also a little entrance in the top box that you took out there. What's the difference, and why do you have 2 entrances to a hive?
This is just a style of a box.
Oh, okay.
I'm not quite sure. Maybe that was why that was placed in there, but
So
not really any purpose.
Last question real quick. This hive here down on the bottom and this box that you have here, are they the same hive? Like, is this empty on the bottom, or are they two separate hives?
So these would be one solid hive.
Okay, gotcha.
And there's one
like
queen.
A two-story.
Yeah, it's like a two-story queen.
Okay.
Ideally, these would both be brood boxes, and as the honey. As it's that time of year, we will add on a honey super to harvest honey from.
Right.
And any additional honey that the bees build inside of these deeps will stay with the bees over winter.
Right.
Bees typically build honey, brood, and honey. And then during the winter, they go dormant during the winter. So with no pollen available, that's what they eat on.
Gotcha. Well, that makes sense. I mean, they're almost like preppers, right? I mean,
Yeah.
bees are like little mini preppers. They got to get ready for the winter. So much stuff to learn, so many things we've already learned, but we know we want to get a little bit more in depth as far as the numbers and maybe even what you can do to start bees in your backyard. We'll never know. Hey, I know there's some more math to do back in the studio, but when we come back, we will have one final round with the bees.
Always nice to see the role that bees play in agriculture, a lot more than most people may possibly be aware of, huh? Hey, we do have phone tutors available until 5:30 this afternoon. We have Simon, a 6th grade student from Reagan Elementary, in studio with us, doing some excellent work so far, and even better explanations on what he's doing. So, are you ready for the next problem? All right, over to the board, young man. You'll be able to write down anything that you think is important to solve this. All right, so here we go. Well, first of all, do you drink coffee?
No, I don't drink coffee.
I don't drink coffee either. All right, let's just go ahead and take a look at the problem. If Mark uses 3 3/4 tablespoons of coffee to make 10 cups of coffee, how much would he need to make 1 cup of coffee? So he uses 3 3/4 tablespoons to make 10 cups of coffee. But we want to know how much he's going to need if he just wanted 1 cup of coffee. So how would you solve that problem?
So as you can see, if it takes 3 3/4 tablespoons to make 10 cups, he wants to know how much he could have for himself, or maybe just 1 cup, anyone. So what you would do is you could just divide it. But another way is, first you could transform this into an improper fraction. So what you do is you multiply these two, and then you add. So then it'd be 12 plus 3 is 15, and you keep the denominator. So it's 15 over 4 is now your thing. And then what you could do is to get a thing like 10 is, so then you divide this equation by 10, or I guess the 15 over 4 wouldn't work that well. So I guess
Right, so it's going to be a little, so you can still get around it. So it's up to you how you want to solve it.
Okay, so I feel like
So 10 is the same as what if you put it in a fractional form?
10 over 1.
10 over 1.
Oh yeah, so then you get 15 over 4 divided by 10 over 1.
There you go. So try that, see how that works.
And there's also a thing, keep, change, also known as keep, change, flip. So you keep this, you change the multiplication, and you flip this to its reciprocal, which means you switch spots.
Good. Nice vocabulary also with the reciprocal on that, and explaining it, how you're going to take the 10 over 1, and that's going to turn into 1 over 10.
So then what you're going to get is you multiply straight across when you multiply with fractions. So 15 over 40. But then when you get a fraction like this, you always have to think, can you simplify this fraction to a simpler form? And in this case, let's find out. So in 15 and 40, what common number can go into them? And when I think about that, I think of 5. So 15 divided by 5 over 40 divided by 5. I'll move down to down here in a second. So 15 divided by 5 is 3. And then 40 divided by 5 is 8. So then your answer would take 3/8 teaspoons.
There you go, nicely
Make
done.
one.
So I like how you did 15 times 1 and then 4 times 10. So what I'd like you to do is, are you familiar with cross-simplifying first?
Oh yeah.
So go ahead, and if you want to, you can erase some things and rewrite that.
Okay. So I guess I'll get rid of this whole thing.
So you've got 15 over 4.
So then I guess what I'll do is, it was 15 over 4 multiplied by 1 over 10.
Right.
Another way to simplify this is you look at the opposites straight across. and then that also makes a multiplication sign so it could help. But look, so 15 and 10, what number goes into them? So let's say 5, so you divide by 5, and then you get 15 divided by 5 is 3, 4, multiply 1 over 2. And then now we check this thing, well, when it's 1, you can't go any lower, and we check if it's possible to go even lower with the 3 and the 2, and you're unable to. So then you can just multiply straight across and get 3 times 1. So straight across, 3 times 1 equals 3, over keeping the fraction sign or the division bar, and 4 times 2 is 8. So that's, I guess, a faster way or another way to getting your answer of 3/8 teaspoons.
There you go. So sometimes it's faster, but the key is it's another way to do it, right? So some students might see it one way, and some see it a different way, and they're more comfortable doing it one way over the other.
Okay.
I want to ask you a question. If you needed 3/8 of a spoon, can you measure 3/8 easily, or what would you kind of estimate that to be?
I mean, 3/8, I guess you could estimate that to be, I guess, almost a half, because we know half of 8 is 4, and then 4 over 8 can be simplified to 1 over 2, so 50%.
Right, so that way you could look at it and go, all right, I need about a half of that spoon, right? That is excellent. That is exactly what I was looking for you to do. You ready for another one?
Yeah.
All right, clear that board, young man. Now we're going to work with some proportions. So here's the problem. Oh, first of all, you said that you liked sub sandwiches and hamburgers.
Yeah.
What do you like to put on your burger?
I like cheese, lettuce, and then every once in a while pickles.
All right. Is there a particular kind of cheese you put on it?
Usually they don't ask, because usually they have like American cheese, so probably American cheese is what I would put.
All right. Well, let's take a look at the problem now. Morgan knows that 15 pounds of hamburger meat will make 60 hamburgers. If Morgan needs to make 100 hamburgers, how much hamburger meat does she need to buy? And what they want you to do is set it up as a proportion. Are you familiar with proportions right now?
Yeah.
That's the way we want it set up. So 15 pounds of meat will make 60 hamburgers. And they want to make 100 hamburgers. So they need to know how much meat they're going to need in pounds for 100 burgers.
Okay, and they want to know how much is 100. So in this equation, you'll see that 15 over 60, which is just 15 pounds for 60 hamburgers. And then you could simplify that to, because divide by 15, divide by 15.
Now, before you keep going, you're doing perfect. If you're dividing it by 15, do you know what you're actually finding at that point?
Like, you're finding how many pounds, like how many hamburgers per 1 pound.
Right, and that's the key right there. You're looking for a unit rate for 1 pound. So that's a perfect way to do that. So continue on.
Okay, so you're going to find a unit rate for 1 pound, so then you get 1 over 4. So there's 1 pound for 4 burgers. And they're trying to find out how many pounds for 100 burgers. In this case, what you do is you have 4 burgers, and you realize 4 times what equals 100. And another way of doing this is you could switch it. So it's 100 over 4 equals question mark. As in, we don't know, that's our unknown variable. So then up here, divided by 4, since 4 does not go into 1, there's an x. 4, how many times does it go into 10? It goes twice. You subtract the 8, and then you put a 2. And then at this point, 4 can't go into 2, so you know you did it right. You drop the 0, so then it's 20. And how many times does 4 go into 20? 5. So subtract 20, and now you're left with 0, and there's no other numbers to carry down. So then 25. But you may think, okay, the answer is 25. Well, that's wrong. Because as you can see, the question mark, we want to see what we put above the 100. And actually what you're going to do is 25 over 100. Or so in other words, the answer would be 25 pounds. Because if it takes 25 pounds to make 100 burgers, then it would take 25 pounds. Then so then 25 pounds for every 100 burgers would be the answer.
Nicely done.
Yeah.
You think you could eat 100 burgers?
I mean, that would take probably a year, to be honest.
A year?
Well, maybe even longer, actually.
One every 3 or 4 days?
Yeah, but
You think you could eat a hamburger every day?
Well, I mean, like, I wouldn't do that, but yeah, I could do it.
That's a good answer right there. I wouldn't do that. All right. You know what? You were doing some excellent work. Do you think you could do another problem in 2 minutes?
I think so.
All right. Clear the board, young man. I have every confidence in you. Here we go. Let's take a look. Another proportion right now. We'll keep you on a roll. Marcia earned $112 for 8 hours of work. At this rate, what will she earn for 40 hours of work?
Okay, so what you're gonna do in this part is, we know she makes this much money in this many hours, so $112 in 8 hours. And then it's very similar to the other one, because what you're gonna wanna do is you're gonna get the 40 and then say 8 times what equals 40.
So do me a favor, as you're doing it, set up the proportion again so some students can see how you would set it up.
It's 1.
There you go.
So then, now that we knew this, maybe you might pop out the answer. But for those who it may take, there's another way to get the answer without just trying to guess and check. You can do 40 over 8. So then 40 divided by 8, it can't go into 4, so you put a blank. And then you see how many times can it go into 40? Well, actually, it goes in 5 if you know your multiplication table. So 40 subtracted from 40 is 0. There's no numbers to put down, so then 5. So then you get 5. So 8 times what equals 40. So then now you know you multiply by 5. So if you get 112 over 8 equals 40, and since you multiplied by 5, whatever you do to the top, you have to do the bottom. So whatever you do to the bottom, you have to do to the top. So 5 times 5, and then let's say you can't do it mentally, so then you multiply by 5.
Now let me put this to you. I'm pretty confident you can do it mentally. Let's break up 112. What's 100 times 5?
500.
All right, so let's put 500 off on the side. Now, can you do 12 times 5?
60.
All right, so put a 60. So what's 112 times 5?
560.
There you go.
So that's another way that you could do it. So $560 would be your answer for this question.
I have one more question for you. Come on over here, young man. You've done those perfectly with great explanations. Do you enjoy doing math at school?
I mean, yes, I would enjoy doing math. Like if I had to pick one subject to major in, I would choose math to major.
There you go. Well, you know what? There's a lot of careers, the more math you know.
Yeah.
And you know what? For some great work today, we're going to send you home with a couple of tickets courtesy of CSUB Athletics. So you can go to any sporting event you like. And I know that right now they've got baseball and softball going on because it's getting kind of towards the end of the year. And I know there's at least one more basketball coming up, so maybe you'll have a chance at that. All right? Yeah. And we'll take a look and see how they're applying math with the bees with the Kern County Farm Bureau and Scott.
We're back. Math in the real world here in an almond orchard here in Kern County, and we want to know more about these bees. Bree has been so kind as to start to take apart this hive for us a little bit so we can see what's going on within each frame. So Bree, tell us a little bit about what you're seeing as you pull out each frame of this hive.
Okay, this frame in particular looks like a pollen frame. The color of the pollen is a distinct indicator on the health, overall health of a colony. As you can tell, this pollen that's packed in here is pretty dry, and that's exactly what we want to see. Anything around it right here, this shiny liquid that's down in here, it's going to be pretty hard to see with such dark honeycomb, is nectar, which will eventually turn its way into honey.
Gotcha. So the bees are out foraging and they're bringing it back, and the pollen is the protein, right, that the bees need, just like we need protein, and the honey or the nectar is like the carbs, right? Am I saying that right?
Yes.
Okay.
What's great about almond pollen is it's 25% protein, so they really get those nutrients that they need. I'm hoping that we see a queen, but we're not getting into any brood, so we won't see her. Here again is another pollen and nectar frame. Let's see if we can get in here and see some eggs.
And while you are looking for the queen is she's the main focus of the whole hive, right? She's what populates the hive. And I know people always ask me whenever I talk about bees, how many eggs can she lay per day?
So roughly an average queen will lay anywhere from 1,500 to 2,000 eggs a day.
Wow. So the population of this hive really kind of can turn over in a matter of weeks, if not a month or two, right?
Oh, very quickly,
Yeah.
very quickly. It takes 21 days for a worker bee from an egg to hatch. It takes 21 days.
Okay,
So
gotcha.
very quickly, you can double your, your colonies, your number of colonies, especially
Wow.
this time, or your number inside a colony, especially this time of year.
Right, because there's just so much food for them to eat in the almond orchards. And of course, that's doubling the size, the population of the hive, but it's also, like you said, helping the farmer out because without the bees, we wouldn't have any almonds.
Right. Bees pollinate 80% of the crops and orchards that we eat on. So 1 in 3 bites that we eat are pollinated by bees. So without honeybees, we wouldn't have the food available that we do.
And so this is part of your inspection process, and you can see that these 8 frames, they all have bees on them. Is there anything else you're looking for as far as diseases or maybe some kind of structural thing that is good or bad as part of a frame?
As an inspector, it's not my job to inspect really any diseases or anything like that, unless it was something pretty scary. But as an inspector, I won't lift frames. As beekeeping classes, and if somebody was taking beekeeping classes with me, doing inspections is very important as a beekeeper, and inspecting your own boxes. You want to inspect your boxes about every 10 days.
Just to make sure that it's healthy and you can do something about it if it's not, right?
Yes,
There you
exactly.
go.
Preventable maintenance inside your hive will save you lots and lots of troubles.
Wow, okay, so you talked about a bee class. So people could have bees in their own backyard, right? You could have a box of
Depending
bees.
on where you live, you have to be county, not city.
Okay.
But if you're interested in beekeeping classes and you would like some on your property and you live in an area that is safe to do so and legal to do so, beekeeping is very educational and rewarding experience that I think a lot of people can enjoy and should.
Right, it's just such a unique deal and not dangerous at all. I mean, I think people have certainly that idea that, gosh, the bee, we don't want bees in our neighborhood because they're dangerous. Well, if they're not coming from a box from my house, they're gonna be coming from somewhere because we see them on the roses and we see them on the flowers and all that fun stuff. So if a student wanted to be a beekeeper at some point, what would be an important thing for them to do in school at this point? Maybe some math?
Right? If somebody's interested in keeping bees, there is all sorts of resources available to learning how to keep bees.
Gotcha.
I always suggest a mentor. There's lots of variables associated with keeping bees, and it takes years and years of knowledge.
Right.
Even myself, am still learning every single day. Even your old-time beekeepers that have been doing it for generations are still continuing to learn.
Yeah. And that's nice, a continual student of life and student of bees. We want to thank you for your time.
Thank you
really
so much
appreciate
for
you
having
having
me.
us out here. This is our famous Do the Math tile. Maybe you can plaster on the side of one of these bee boxes that's over here, and maybe we make a little dent in the bee world.
Thank you. I love it.
Learned a ton about bees today, learned a ton about the numbers that go into it, but especially about how they're so important for the agriculture here in Kern County. At this point, though, the bee day is done. Back to the studio.
All right, thanks for that, Scott. And once again, also, thank you to the Kern County Farm Bureau and all of the help that they do provide us with here at Do the Math. We do have phone tutors available until 5:30. We want to say thank you to Simon for being in today, a 6th grade student. Since you like doing math, have you thought about a profession when you get older yet?
I've been thinking about professions such as I could major in mathematics, maybe physics is what my dad's interested in, but then I'm also interested in becoming like a doctor, something that could help other people.
There you go. Great aspirations right there. Did you have fun today?
Yeah, I had fun
All
today.
right, we certainly did enjoy you being on. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.